yourself a little bit more extensive than normal. Yeah?
All right.
Okay, floor is yours.
Thank you. So, hello everyone. My name is Markus Netteler coming from Bonn, Mondialis. We have a startup existing for now almost 5 years. I'm originally coming from research in Italy, and I'm the project coordinator of the GrassGIS project and also co-founder of OSGeo Foundation. We thought to bring GrassGIS to the next level in the last years, working on that. The main author is Sören Gebert. He spent most of the time initially on it, and we are working on this software. This is our very outdated company picture. It's, let's say, an approximation. We have more people now, but maybe giving you an idea. River Rhine in the background, so we are near Cologne. And interestingly, and we are in an open source context here, you can make a living of open source software, in case you didn't know. The entire company, along with our sister company, Terrestris, which exists much longer, since 2002, are full open source companies. And this is something which I still try to repeat everywhere where I can, because it's an interesting way of developing software and offering services. So what I'm talking about, we had some idea. It's a bit small. I hope you can read it. I wasn't really prepared for low resolution, but I can tell you what's written there. Bring the algorithms to the data. So we heard in the previous talk that data can increase and do increase non-linearly. And in our case, we are dealing with geospatial data, including Copernicus data. So also there are petabytes of data everywhere, and those have to be dealt with somehow. And everybody is dealing with I/O problems and disk storage and so forth, and why not go where the data are? But this also implies kind of bringing the user to the data. So this paradigm you have probably heard of already several times, and it's still valid. We wanted to check how to exploit the GrassGIS software particularly, but not only purely Grass, but all the related ecosystem with GDAL, Proch, ESASnap included as well, and whatever you want to deploy yourself, how to get this into some kind of cloud context. So the original name was Grass as a Service, GRAS, which is not so intuitive probably to pronounce. For marketing reasons, we then called it actinia. Actinia is a sea creature, which is like having tentacles and filtering the water. So now we consider like something like data lake or the flood of information or whatever you want, up to you. And so with our analysis software, we can go there and fish the relevant information and go for processing that. Of course, core element here is GrassGIS. And this software is, if in case you are not aware of it, under development since 1982, so way before I left school. I joined in, let's say, as a shy user in 1993, and then moved on to basically, more or less coordinating it. You know, it's a duocracy, means who is working can move things, and I thought to contribute to that. If you are not familiar with Grass itself, we have something called Grass Database that is more or less a file-based system with SQL database in the background as well. But there are a few particular things. One thing is called location, and there are inside map sets. That's more or less for the organization of the data. You could also consider this as a workspace or as a project and subfolders. So nothing dramatic. But there's something related to that, because this brings the possibility to offer user management. So probably you do not want to share, especially in a cloud context, you don't want to do that, share all data with everybody, but you want to have a restrictive user model there, and this is coming kind of implicit here. Then we have lots of algorithms. We are talking about 500 plus methods available. Majority is in the core. It's vector analysis, raster analysis, volume, so volumetric data analysis, time series, which is not, so in terms of grass age, it is new, but it's already existing for 7 years or something. So you have space-time cubes, and you can go and analyze things with algebra as well. And all this is already there. You have image processing, which we use for the Copernicus data processing or meteorological data interpretation and so forth. And what you can do here, since we are in a GIS context, you have the full integration between image processing and GIS in one shell. So it's not two distinct worlds. I'm not interested in that. I'm a geographer myself, so I like to get things together. And here you can do that, and you can just smoothly go from one to the next. So now the question is how to get this into the cloud. And cloud means we want to have a RESTful API on top, maybe to start with, to list what data are there, what does belong to whom, spatio-temporal data set is offered as resources. So you can then go there and do naturally computation on top of that, enable usage of GraphGIS modules, and the already mentioned user management. So define different roles, but in a cloud context where you pay as you go also for the resources, you want to have some control over what you offer to the user. For example, you offer to the user, being a provider, a kind of a flat rate, but flat rate doesn't mean unlimited, of course, but it means flat rate in the context of what they want. So you can go there and say you restrict to, it's like geofencing, to a particular area of the world where you can compute things or amount of data volume and so on. There are different possibilities, and you can also expose the methods you have, or the modules called in GRASS language, selectively to the users and say, okay, we offer you this stack of functionality, and if you want level 2, then you can also access the other one. Interestingly, you want to avoid that one user overwrites things of the others. You have to have kind of data locking, also natural, but you have to implement it. And this is also coming already with GraphGIS itself. So if you take apt-get install grass or DNF install grass or whatever you do, Docker pull grass, yeah, then you have the possibility to already use a network drive and using the Unix or Windows user management, yeah, to have access or not. And all this is now exposed through Actinia itself as well. We have two kinds of storages. We have the persistent read-only storage, where you offer base cartography, for example, like the original data, like what it is, elevation model, Copernicus data, land use map, whatever it is. You already provide to your users, it would go there, because you do not want that anyone modifies them. But the users, through the computation, here are different workers or nodes. They want to write their own stuff, and so that goes into the user space. And this is also connected to kind of garbage collection. For example, in ephemeral processing, you say the data, the results are available for whatever you put there 24 hours, and they are deleted automatically. Just housekeeping in order to avoid that too much storage is used. So in the end, you have this GRASS database over there, which is the data storage, can be whatever, I come to it later. And you have the different workers equipped with GraphGIS, also GDAL, PDAL, PDAL as well, I forgot to mention before, whatever you put there basically. The user management is done in Redis, and there we can we have an Redis instance, and the systems are communicating to each other and so forth. Everything then can be deployed on different cloud infrastructures. So this is all Docker-based. We have running instances in OpenShift, Kubernetes, and OpenStack, and also others. We're using Terraform in order to deploy machines. So kind of, if Actinia wants to scale up, we can say, okay, you can order new machines by yourself, and after consumption means the finishing of the process, the machines are destroyed in order to not generate further cost. Then we need a load balancer. So the incoming requests are coming here from through the API, but you want that let's say the cloud resources are optimally used. For that, there's a load balancer then sending stuff to the different workers, and ideally, well, the data are visible anyway, but you also, in case you have a heterogeneous cloud resources like these instances with different flavors, you want to send them to the right worker in order to be able to compute the job. Okay, now how to control all this. We are having JSON files here. We have the REST API. So there are requests like get location. So that is, you can use curl, or we have some other interface, or the web-based system, or maybe in the future also QGIS-based one. You can call it from Graphs command line. So different ways of retrieving information. You can query the system and ask, okay, what data set are already there? And there could be, yeah, there's, for example, the global, in our system, the global SRTM model, the elevation model that is a 200-something gigabyte geotiff file. And in case you are working with elevation model, I think most of you will only be interested in a subset, but each of you in a different subset. So the idea of cloud is we offer it once, and then you can just operate on the area of interest, and which could be changed dynamically. And then, as it is REST style, you chain more stuff there. You say, kind of zooming into North Carolina, that is some OSGeo sample data set. What is inside? So we're in North Carolina here, and then you see what data sets are there, and you can go on. And you can go further, look into the maps, and you see there's already a render endpoint, which means if you query the system, and by the way, this is online reachable under actinia mundialis.de. You can go and play. There's a demo user available. Yeah, then you can go into dive into these data and also use them for computation. Now, user-defined processing. In this case, you don't retrieve, but you send something to the system and say, please do this. And that is a post request. You see over there, post request. And you say, I want to compute the slope of some map, and I want the result as a geotiff, please. And what's also possible, by the way, you can also give it a URL. It's not shown here because it's too long, but you can specify URL. In this case, this data set will be retrieved first, and then computation being done on top of that, or you intersect with data already there, or you fetch from different data sources and compute stuff, and eventually you retrieve either a vector file or raster file, or you dump it into a PostGIS database or whatever you prefer. And through this, in JSON style, you can write custom process chains. Already mentioned, Graphs modules are there, importer-exporter is there. And then you can also bring in your own Python scripts, and those can be whatever. And if you say, oh, but Python, no idea, I still have my good old 90th shell scripts, they work so nicely. No need to rewrite them, you just wrap them into a Python script and hang them in, and you are done. So it's not that you have to rewrite everything, but you can just make it appear a Python script, and the system is happy with that. We have also wrapped, you find this on GitHub and Docker Hub, Snap, ISA Snap. We made a Docker image out of that. By the way, it's a fraction of the original size. There are some funny things in the original, like full Java and so forth. This can be heavily reduced. And through that, we built up the entire stack. So how does a curl request look like? So there's, of course, curl, then demo user, please steal the password, it's public. You send a post there, a process chain. It's only written like a variable there. This is essentially a file, a JSON file, or maybe you put it into a variable, up to you. And this is then sent to this endpoint here, and it will do, in this case, asynchronous processing. That means with synchronous processing, you say, okay, do that, and I wait till you are done, and it comes back to me. But in case the job is something complex and it would run for several hours, you don't want to sit and block your terminal with that. You use the asynchronous endpoint, and then it is sent there, and you have a URL with a resource of status, and you just ping it from time to time. This you can automate, of course. If you have a web interface, then it would notify you once it is done. So both options are available, which means polling in this case. So you get the status, and once it is done, you get the resource URLs back, which is the geotiff or whatever it is. And then you can retrieve the map and you are done. What else is there? We have been implementing processing chains for Sentinel-1 and Sentinel-2 data, also for Landsat, not written here. There are endpoints like NDVI. So for example, you have you're interested in a normalized differences vegetation index, a very common index used in agriculture and elsewhere. Also to find green areas in urban areas, you can use that. You just say, okay, I want to analyze in this area, and maybe for the year 2018 from 1st of April to end of June. Search something, a scene with less than 1% cloud, and do the NDVI. So this is more or less one endpoint, and then you say just these few metadata, send it to the system, and you get stuff back. We have connectors to ESA API Hub. That means there the Sentinel data are retrieved from one way. We are in discussion also because we are involved in the OpenEO project, which was mentioned earlier, to connect to the DIAS platforms that are Copernicus platforms for Sentinel processing. The Amazon AWS and Google Cloud Storage, we have also some deployments there. Advantage is of those, the Sentinel data are already unpacked there. You do not have to retrieve the entire full zip file of 1 GB size if you are only interested in 2 channels. Yeah, then you can switch to that provider. You can see it's flexible. Yeah, our idea is to not be locked into one single platform, but to have the possibility to to deploy it here and there and use the best. So example here, Sentinel-2 processes the endpoint, compute NDVI, and use this scene. The scene name I got from somewhere, but you can also search for it. And then, as before, you can poll for the result, and then you get the NDVI back. And this you get like a screenshot, so preview that you see what you have done, plus the geotiff file as well, which is of course a bit larger. Okay, some more features. You can also write. You can write to Google Cloud Storage. You can write to your own. If you deploy Actinia yourself, could be your laptop even, then you can naturally write also there, or to S3 buckets. Then we have added for the GRASS users here the possibility of an Actinia command execution. That means you have one GRASS command, you just write ACE in front of it. Of course, you need to have the credentials. And then the same command is sent to the cloud. So not locally executed, but in the cloud. So you can play around, prototype on your laptop, and once you know, you set the resolution. This is one of the nice GRASS features, to the original resolution, and do the heavy computation in the cloud itself. As mentioned, we have an OpenEO support there. We are one of the backend providers. We will probably not fully implement everything, but no backend implements everything, but the relevant parts. And you find on GitHub the related information, also on OpenEO ORG site. That's a Horizon European project, by the way. If you haven't been here this morning, you can see in the video archive of today the related talks. And then eventually something very interesting called Actinia Algebra. That is something to do massive computation in parallel. Since we are on cloud, we also want to make good use of that. And imagine you want to compute something of an entire country, watersheds, vegetation index, runoff, whatever you can imagine. As I mentioned, can be GIS, can be Earth observation. Then all the stuff is parallelized and executed in much faster time. Of course, you need to have some more resources for that. So, what's upcoming? We are almost through with implementation of process self-description. That means what you saw, this is almost last slide, what you saw, that we can see what data are there. We also want to have what methods are there. Yeah, a kind of catalog. And if you want to maybe then wrap around something like WPS style, yeah, then you can make use